Hi everybody, welcome to part 2. So here's the big answer, the little equation that shows how mathematics and the universe are just the same thing. The universe comes in quantities, entities that bring themselves into existence, and relationships between entities. So is mathematics the same as that? It certainly is. Here it is. There it is, the new equation, the new star, E and pi. Now E is the base, the natural base of all numbers, quantities, the natural base. This is how we describe arithmetic and calculus and algebra. It must have something underneath it all that brings things into existence. It's called the natural logarithm, and the definition of that is something, if I put it to E, gives itself. It brings that into existence. And pi, the natural constants that underpins relationships in the universe. Pi comes out in equations of atomic, quantum particles and gravity. It does everything. All of mathematics is just the same as the universe, separated into quantities, arithmetic, algebra and equations, and relationships, geometry. And I put them together, I get mathematics. Here's the little equation that describes how the universe brings itself into existence. Now there's something very important to state about mathematics, and this was brought out in a mathematics conference in 1931, when the brilliant mathematician David Hilbert stands up and declares that mathematics must be completely consistent. But the day before, an even more brilliant man, Kurt Gödel, had stood up and showed that there are some things in mathematics which can never be proved, and that would always be in the quantities, in the arithmetic. Geometry always plays out. But there are some things in mathematics that cannot be proved, but we know they are true. It's called the incompleteness theorem, and that means the universe is incomplete. We don't know what the animals and plants and chemistry will look like in 100 million years. It's not finished. It gives us a new definition of what infinity is. It doesn't mean it goes on forever. It doesn't exist. It means I can always generate another one. But it's finite until I do so. That clears up a lot of problems. So how do you use this to show how the universe generates itself? Quantities that get into relationships which make more quantities. When quantities get into relationship, they change into something else. Now that can be elements changing into ever bigger elements. It's completely different. I've got something new that wasn't there before. An atom, a nucleus that gets into a relationship with an electron. I've got something that behaves completely differently. When a planet gets big enough, it can change into a star. It changes its behavior, or a wave changes into a particle. It could be a wave and a particle at the same time. That's already been proved. We've done experiments that show that molecules go through the double slit experiment. Relative to each other. It's all relative. They're still particles, but relative to the equipment, behaving as a wave. So what I'm doing now is taking the next step from Einstein and showing that it's all relativity. Everything must exist relative to something else. Even a black hole is just the space which is being distorted, and there's something which is distorting it. There are no singularities anymore. So it's another step. But I need some mathematics that shows how the universe goes from simple to ever more complex, so I can explain chemistry, biology, and social systems. And here is that mathematics. And it's been sitting in books like this for 20, 30 years. And he states in this book that this mathematics transcends the physical components of the system. There's nothing to do with them. It also transcends the fundamental laws of nature. But this mathematics is an exact copy of how the whole universe works. This mathematics has its own forces. Mathematical values which attract entities in systems or repels them. It also has two little constants which are transcendental. That means they transcend the whole of the rest of mathematics. E and pi transcend the rest of mathematics because they're not algebraic. I can't get them to zero. I can't get rid of them. It's always a duality. So I'm going to use this to start explaining reality. This mathematics has something, it has mechanisms which do allow things to become ever more organized. I get order from disorder. So now I've got to change my number systems in mathematics, where we've had the real numbers which represent matter, positive, electrons, energy, negative, and imaginary numbers for space and time. And now I must add in complex numbers. So time goes this way when something is breaking down, becoming less complex. I must have two. Everything's a duality. When a star explodes and releases the elements, it goes this way. When the star gathers itself together, it's going this way. And still in physics, we say that life and stars and gravity is negative entropy. We must stop that. It's positive self-assembly leading towards greater complexity. And there must be some mathematics that has self-organizational criticality. There it is, fractals. So there, he states in the book, that's what it does. It can go to something which just becomes ever more complex. The solar system becomes a clock, but then it stops and balances itself. And that allows the atomic level chemistry to take place on the Earth and become ever more complex. And it doesn't matter that it's not deterministic, because remember, it's just under the umbrella now of mathematics. We've taken physics down from the top. I've got physics, quantum physics, chemistry, biology, the weather, social behavior, all underneath this big umbrella. It doesn't matter that some parts are probabilistic, some parts are deterministic. Now it makes sense. I've got some information which is consistent. Quantum physics, which is probabilistic. Now if I'm a geneticist, I say that's just what I'm looking for. People say it's a big problem. There's randomness. Well, you need something at the atomic level that generates complete randomness so that I get an even number of males and females in any population. It must be absolutely random to give a 50-50 chance. I mustn't be able to know what's going to happen. And probabilities, seen as a problem now, but as a geneticist, it's just what I'm looking for. When Gregor Mendel starts putting the mathematics on his P's, he finds probability distributions. That's just what I want to find, something in DNA that will give me that. Now it's all okay, because I'm not saying it has to be deterministic. The solar system has parts which are deterministic, like the orbits. If I look inside the rings and belts, it's complete chaos. But notice it's tied up into rings and belts. So there is a pattern. Seeing a pattern there in the solar system. Everything must be a pattern. Now that I've got something that works, now I've seen that randomness is only random at the individual event. In any population of events, it leads to ever greater order. Now we've also seen that with prime numbers. Down at the bottom, prime numbers build the other numbers. Look how this mathematics works. I take something, split it in half, put it into relationships. Number 6 will have something to do with it. Now we've been looking at this relationship for thousands of years. We've seen it before. Here, if I look at honeycomb, is it a circle or is it a hexagon? Or is it both? They're very, very closely related. Let's see how it works. I've been allowed to come into schools here in Tatonga and teach this to children. I draw my circle. I take my radius as 1. I put it into 6 parts. They're not quite the same. I've got a little bit longer to go here, a tiny asymmetry. An asymmetry we know the universe needs to exist. A little asymmetry which has already been shown between antimatter and matter. It's a mirror with a little bit of difference, and that difference is what gives me an existence of ever greater complexity. So let's look at that. There must be something in here talking to me. This relationship between six. I break something down into a half. I split the whole universe into forces and energy. Then I split the forces into gravity and atomic forces, and atomic forces into electromagnetism and strong and weak nuclear force. And they both, electromagnetism, they both separate. The strong and weak, and putting them together. Gravity must have a partner. And that partner must show up in here. And it does. Again, it's Einstein showing as equivalence that something's equal. Something that balances a planet when it stops and goes into orbit. And it's here. I've got the laws of conservation. The conservation of linear momentum and the conservation of angular momentum working together to balance the pull of gravity. And we know that that has to do with mass, that resistance of acceleration. So I know that this is related to the Higgs field, the Higgs boson. And now I can just start to look at everything around me and say, it's all going to be these patterns. A pattern of, if I split 2, a circle into 2, I get 3, a relationship between 2 and 3, which is the first prime numbers. 1 is not a prime number. I go right down to the base, and I get these little trilogies, transcendental numbers, E and pi. And the relationship between E and pi is here, in the circle and the hexagon. If I take that, I've got a 60-degree angle here. I get 0.866, the sine of 60 degrees. And if I take pi times the sine of 60, it makes E. So E divided by that gives me pi. They make each other. This makes this, and this makes this. Sitting underneath my equation. But this is for the transcendental part of the universe. All the stuff which is not material. Well, the universe is only 4% material. The rest of it's all this transcendental stuff. Antimatter, matter, it's just empty space. But it's not really empty. It's cancelling itself out. Matter doesn't cancel itself out. It's still +1, -1, but it adds itself together and brings itself, holds itself in existence. So I've got numbers here that show that. 0, +1 and -1. Remember, these are not prime numbers, but it doesn't matter how much matter or energy I've got, I add them all back together and I get 0. It's this relationship here, a relationship between 2 and 3, which I see here. I separate the universe, separate again, and I get right down here to a relationship between 3 and 2. The quarks inside a proton. I've got 3 different ones, but 2 are related. So I've got up and down, but 2 different ups. The electrons are neutrinos, but I've also got the photon, which is neutral, sitting by itself here. And that works for the bosons in the weak nuclear force. I've got 3, but 2 are related. The gluons, 3, but 2 are related. The forces themselves, I've got 3, but 2 are related. And this uses the conservation of linear momentum and the conservation of angular momentum to balance it. So it's making sense. So I start to just look at things like this around me. There would be a very, very simple, big system, not like the solar system, which has self-organizational complexity and structure with all the parts in mathematical relativity. That third component which I've been looking for to add to this so I can describe reality. The biggest kind of systems, just gravity and these 2, I've got 3 making itself. There will be another system the same as that, which works with the atomic forces, and there it is. So I've always got the big and the small, and I've got everything in between. I've got the atomic level, I've got the gravitational level, and I've got the complexities in between, and that means us. So now I can use this mathematics to describe reality. I've got 3 components. I've got relativity, atomic relativity, and mathematical relativity sits in here. So I just put that and put that together to make solar systems, put that and that together to make chemistry, the weather, evolution. It's all no problem now. And I start to look at mathematics around me just to show you how the mathematics of fractals and reality are the same. That's just a mathematical pattern generated by a computer. And that's a real fossil that's 350 million years old that I found when I was a little boy. I never thought I'd be doing that. So here we have a simple explanation that tidies up a whole of science. It's consistent information. No more nonsense. No more stating, as we do now, that other universes must be generated to explain the probability of the wave function as it collapses. Complete nonsense. We're not allowed to experience these other universes. Complete nonsense. Because we're trying to stuff it into physics. It doesn't work. And this is simple. I teach it to very young children. So here's something that Brian Cox said a long time ago. There's a mystery at the heart of science, for which as yet we've no explanation. And that is, this universe is simple. Underlying all the complexity appears to be a magnificent simplicity. Nowhere is that simplicity more obvious than in the construction of the elements. And he's right. You can use this and the little relationship between 2 and 3 to construct the elements. I need 3 components to get complexity. I need a nucleus made of 2 components. Complex, I have to add a 3rd component. But to make a neutron, I need 3 components. I need a proton, a neutrino, and an electron. I'm building ever more complexity. As soon as I get atoms and start putting them together, my complexity just goes until I start to get living things, social behavior. This explains why people do such strange and stupid things, because we are just part of this mathematical system. We can transcend it. Once we can see that we're just doing things, we copy and compete to see who can do the most stupid thing better. We can stop doing it. We can start to teach children that these beautiful patterns that we see all have meaning. This is my favourite. This is a bee's eye, which I photographed. And I can see this beautiful relationship between circles and sixes and the lens, the circle itself. That beauty sitting down at the bottom, simplicity that we've all been looking at. We know is there in snowflakes. I have my overall pattern. But the details now can all be non-deterministic. It's okay, I'm not contradicting any laws anymore. So we're going to be making a lot of programs to show you how to use this. And if you're a parent or a teacher or a lecturer, how you can use it for human behaviour. You just obey some simple rules, and if you know what those rules are, you can make people respond uncontrollably. What a difference that's going to be. And this, those of you who are good at mathematics will have recognised that in here are all the components to the biggest problem in mathematics, Riemann's hypothesis. So now we've got an answer. It's a mathematical universe. It doesn't matter what the components are. I don't look at bees and flowers. Photosynthesis and respiration are mathematical mirrors of each other. Just to show you how different they can be, that's a insect population graphed against its birth rate. This, you can see it's the same pattern. Is that a little circuit which can be induced into instability, into chaos, and back again. It's the same pattern. So I stop looking at the components. The components don't matter. It's the relationships. It's this relationship here which starts it all going. There's nothing which exists which isn't just a relationship. So I can state the universe is not